Welcome back, everybody. Now we're going to jump into one of our more popular sessions from past events. It's Hidden Gems. So this is the part where we like to look at some of the underutilized tools or capabilities that maybe you aren't as aware of. And this is part one. So part two will be this afternoon at 1:30, I believe. So first we'll hear from Sam again, who'll be looking at some synchronous modeling and part modeling capabilities. And then we'll hear from Kevin, who will demo some sheet metal design tips and tricks. So now let me make Sam the presenter and pass it on over to him.
All right. Good morning, guys. So hidden gems. Here we're going to take a look at maybe, let's move my mug over here to the bottom right. There we go. So we're going to take a look at some of the, oh, we call it hidden gems, or also maybe you can also think of it some of the, I don't know, forgotten favorites back in the past that sometimes get overlooked, but they're powerful tools within inside of Solid Edge that we can utilize. The first one I'm going to be touching on is called multi-body modeling. So what multi-body modeling is the ability to design multiple pieces or multiple parts within the context of the same part file. So with this type of environment, you can use this for in this particular, like for instances where you create when you have a part that contains multiple pieces, but at the end, maybe the BOM only needs to call out one single part file, one single number, one part number for that main component piece, but these other little components help make it up at the very end. So we see that in like fixture making, jig making, but also with parts that go down and get assembled, say on the production line. They don't necessarily uh, have have a part number or considered a consumer part for the extra add-ons, but yet these little pieces need to be accounted for somewhere. So Solid Edge has the ability to capture that information and help you utilize that data within the single part model. Now, with multi-body, it can consist of, say, regular. You can mix different component pieces, so you can have part files, you can have sheet metal files within there. It's just they behave according to certain rules that you have to follow. With sheet metal, you can't have two disjointed pieces, and with part files you can. One other thing is like the material. Once it's set, it gets shared, but it's a powerful little tool that we can use, and what we can do is we can call it out. We can have this multi-body part, call that as a single part, or if we can choose, we can have it broken out to a separate, I want to say, quasi assembly, because it's being controlled from the master part. So it's a very cool little tool that we have here. So the different parts that we can have, again, we can have design bodies that can be part or sheet metal. Okay, they can be modeled in either ordered and synchronous, so that you can mix the two environments together. We also have you know the part file, as you mirror, as you're designing in a part space, you can draw two parts separated from each other. So those rules still apply within multi-part modeling. So a sheet metal part can't be disjointed, but there's some ways around it. And one of the ways that we can kind of get around that is by creating what we call construction bodies. So a construction body usually is a collection of surfaces until we tell it either to attach to a part or convert it over into a design body. And you'll see that over there in the Pathfinder. But we do have the ability to make those as well here in the multi-part environment. Um, they won't construction bodies don't show up in drafts, so that's the only they don't show up by default inside of a draft. But the other thing too is we can't publish these out as individual piece parts until we do convert them over, and we'll touch upon that here on the little demo side that I've got prepared for you. So here I have I'm going to open up I think it's like a more of a jig fixture or a tooling fixture that's going to require some extra piece part components. And with the extra piece part components that it needs, I got some part plates that need to get attached to this, as well as the sheet metal part. So you can see that right now it's just a regular part file, and I already created one of the plates over here on the left hand side. So from the actual part environment, I'm going to come over to add a body. This is the multi-body command. Here I can choose which type of body I want to add, either a part body or sheet metal. It goes and pulls out a template from the edit default creation templates. So this part won't show up in the design in the design bodies quite yet until I actually go in there and actually create it physically myself. So there, what I'm doing now is just kind of getting the outline of the sheet metal part that I want to create. And I want to create a sheet metal part that goes on the outside of this. So again, what I'll do is just trim up the edges. So I'm using Project Sketch as the fastest way to get the profile that I want. But at the same time, I'm kind of trimming everything up that way. I make sure that the material's to the outside. And one piece that I won't need is this outside leg because I'm going to use a contour flange and I can't have a closed body in a contour flange. So right now, you can also toggle the display between the original design body too, which makes it easier to do your trim and extend. But going in through, creating my contour flange, set the thickness. I'm going to thickness to the outside. Okay, and then give it my depth or the width of my actual sheet metal component part. So there, quickly go ahead and design it. So you can also think of this as designing in context of a top-down assembly creation. But there's my left bracket. So as soon as I create it, it'll actually show up inside my Pathfinder there. So now I can finish off my design. So if say I want to go ahead and cap both of the ends, say this is just a little protective case around my tooling piece, I can still use all the synchronous, all the sheet metal components. I'm actually in a this is actually, considered a sheet metal file at this point when I'm activated within this part. So all the commands still behave the same way as they would as if it was an independent part and I was bringing it into an assembly. The only thing is you don't get all the fancy assembly relationship tools that you have on the assembly side. So pull some tabs down, create my flanges. So there's my cap. So this is actually, I got a back face, got the front face, but say I want to go ahead and duplicate that over to the other side. So I have right hands and left hands. Okay, now got it prepped up. I got a mirror, I got a plane over here that I can mirror about. So I can select the part that I want to copy over and then go into my mirror command, but you'll notice that there's an error that will actually pop up when I actually try to do this. Now, this error that's going to show is going to tell me that I can't do it because, the mirror faces can't attach to the model. That's because, with a sheet metal component piece, I can't have disjointed pieces. So what I can do is I can call it a detached face. So it'll copy it over actually as a construction body. Okay, so this is how we this is how we get around that little disjointed body issue. Okay, so once it's over there as a construction body, a collection of surfaces, I can right click and toggle it over actually into a design body. And it actually changes color and it moves it up into my design body container in my Pathfinder. Then it's just a matter of just renaming it from, the current name that the system gave it over to my right hand bracket or my right bracket that I've got. So there I've got my two sheet metal pieces, and then I just need to rinse and repeat on the plate that's left for me over there. So same thing here. I can mirror it over using the same plane, but what I want to do is I want to activate into it first. And you'll notice the color shift, from the dull color to the brighter color, and that tells me that I'm actually in place activated. It's kind of an in place activation within that part. Okay. So that tells me which one is active and which one I'm actually making changes to. You also notice that the menu bar changes. So if you look at my AI up there, it's got a box on it, so I'm in a part modeling environment. So same thing I did with the other one, I can toggle it over, make it a design body because I did detach it. So there it is attached, and simply come over there and rename the actual component piece. So this would be my right plate. Okay. Now that I've got my individual component pieces here, if I were to take this straight into a draft file, okay, first I'll activate my main body because that's the one I'm going to be working with. I can also designate it as my assembly body too by just right clicking and say, hey, activate the assembly body. Okay, so then you notice it's got the cool texture showing up on that original part, but save it, of course, save it before you do anything else. And then I'll take this into a draft environment. Okay, so let's go ahead and go open, go new drag this in, and the way it's gonna get placed, you'll notice that this is still a part file. So in essence, what I'll end up with over here when I place my, let's go with the ISO real quick. ISO view here. What I'm gonna end up with when I place my parts list, it's gonna be one single entry because the solid edge, this is still a single part file. It's just multiple bodies in it, but it's not gonna recognize any of the new parts that I added in. So let me go ahead and change this out. I still had the old setup that I had. Let me change it over. There we go. You know, we can store multiple settings in there inside the draft side. So that only shows one part. It's giving me the part number or the part name for the actual component, main component piece, but it's not giving me the other details, right? That's not going to happen until we actually tell the, you know, if we need it. If we didn't need that, we don't have to publish out. But say I want to go ahead and, you know, get a parts list out to the guy that's making this jig piece. I can come over and just do a multi-body publish. Okay, with multi-body publish, what this will do is it'll actually separate the components in each individual part files and then allow me to call them up over there inside the draft too. So very first thing I do is set the path. So maybe I don't want to mix the files within the same file directory. I can go ahead and place those into a separate folder. And you'll notice that once I selected all of them, I don't have to do one at a time. I'll keep this one in the same one. And what this is my assembly, but this is my dummy assembly file, because what ends up happening is after I save the files, it'll create a link between this part and each one of these subcomponents that it's saving out. So you'll see a little chain link. You know, that's showing me that two parts are linked. If it's out of date, we'll take a look at see what happens when it's out of date. But this now becomes the controlling master file. So any changes I need to make, I would make it to this particular file here, and then that would push on the changes after I publish them out over to my dummy assembly that it created. So if I load up my dummy assembly, you'll notice that it has a link over there on the left hand side showing that it's linked back to a part. Sometimes it's what's it called, assembly copy, I believe. Yeah, so this is kind of like an inner part copy. We'll talk more about that in the second hidden gems when we're talking about inner part relationships. But those are all my component pieces now. I've got my main body, my design body number one, and the two extra pieces I made. So now if I take this assembly and now place it into a draft, in this particular instance, let me go for an ISO again. There we go. Pop that guy in there, and then we'll go ahead and go for a parts list. And I may have to go in there and change it because, yeah, I still have the old setup there. So let's just quickly cycle through our pre-saved configurations. Let's go back to an ANSI. And there you can see now I have balloons and callouts for each individual component piece. So if I go back over to my original part, remember this is the one driving the rest of the model. So if I go in and activate, say, this left body piece, okay, I can activate it. You'll notice the color shift. Now I'm in a sheet metal environment because I'm kind of in place activated. And say I want to go ahead and drag this face out, make a change. You notice that because it is what's it called? It is mirrored about a plane there, how both sides automatically change. Now, of course, I got my design intent turned on over there. But if I go ahead and just kind of pop over and give it an 8mm extension, you'll notice both pieces change. Okay, so in order to get this pushed out into my draft file, I will have to come over here to my, it's not going to update automatically over here till I actually publish it out. So if I go back to my original part, and there's a command underneath add body called multi-body publish. Same one that we went to before, but you notice that my left bracket, my right bracket now have little clocks on them, as well as my assembly part, my quasi assembly. If I go there and save the parts again and update them, let's go ahead and close this because You don't want to have it open when it tries to write a file. So kind of Windows 101 Windows rules. Can't have a part open when you're trying to update. There we go. So there I got my clocks. And if I click save file over here, I can go ahead and update each one of those pieces of data, and Solid Edge will do its thing, re-update, reconnect the links and everything. So when I go and actually go back, say I want to go back to the draft, I do need to open up the actual, I may have to go back and actually open up the actual assembly again just to update it, but there we go. Let's clear those out. Close out the changes, but you can see that my draft file there automatically picked up the change from the assembly. And if I go back to the actual, the dummy assembly they created, I can see that those have been updated as well. Okay. So if I click no, of course you'll get the black marks, but we just have to go in there and update each one of the views as we go through it. And I can add multiple views. We can get into adding more parts. But that's one of the more powerful, that's one of the kind of things that are forgotten. If you're dealing with sheet metal too, if you want to do a quick little sheet metal part, you can do that. But it's a pretty cool little thing. The other one is kind of a bonus thing. This kind of ran into one of those technical issues. So not only do we do, so we're here on the support side as well. We get different cases, and one of them that's pretty cool to share is, we have a helical option inside of Solid Edge where we can draw different types of coils, mainly for springs. But one of the kind of the things that came in, and it's pretty interesting to take a look at, is how do we get the length of one of these? Get the length of a helix after it's already been created. So if I went in and so if I have a already created helix, what I can do is I can create a center point over here on the actual coil itself, drop a point down, and then use that as a guide to create what we call a helical curve to get the total length of this. Let's say we want to uncoil it. But first thing I need to do is just kind of grab all the parameters. Okay, so I need to understand what makes this, all the dimensions per se that make up of this helix. So this was already created. So the actual length of this little guy here is like 9.870 inches, which is long. So I go and you can write this down either in a text file, or you can copy and paste it over here on this side. But there's my length that I need to go ahead and capture. I also need to capture the turns and the pitch. So those are there listed in the little dialog box over there on the side. Now, to go in and to create a profile that I can edit, one, you got to make sure that that point is actually there on that circle, because that's what I'm going to use to create what we call. So we have a helical command over there inside of the solid bodies, and then we have helical curves over here inside the surfacing area. So what I'm going to do is just pick the point, pick an axle or an axis per se, and then I'm going to go ahead and zero in on that endpoint that I created in the center of that circle. And then once I do that, I can enter in the parameters that I wrote down at the very beginning. So pitch and turn, I got the length already preset up, number of turns, right hand, left hand. So we got all the same 3D helical parameters that I had over there inside the part environment, but I can go ahead and capture those over here inside the curve to create the same path. Okay, and once I create the path, now I have something to measure, because without this I couldn't come over here to measure. And now I can select the actual curve that's linked in there, and you can see it show up there. It's about 44 point, I call it 45 inches. So that gives me a baseline to tell me, okay, maybe how long that actual coil is. So one of the cool things, I mean, it's kind of not one of those everyday type of things that you may think of, but it's, we call it one of our hidden gems that we use forgotten favorites that we can come back in and try to use. But that with that, I will transfer it over now to Kevin, and he can show us some more hidden gems that he's dug up for us.
Hi, my name is Kevin Grayson with Siemens Digital Industry Software, and I'll be hosting this session on solid edge sheet metal. Many of you today are designing or utilizing sheet metal parts designed by someone else in your machines or in various other applications. Today, we're going to demonstrate how you can work with geometry coming from outside CAD sources. We're going to focus on how you can optimize the data for maximum editability and then convert it for downstream applications and added benefits such as flat pattern creation for manufacturability. Let's take a look at this first example. Obviously, if we look closely at this part, it looks like it's a sheet metal part. If you've ever worked with sheet metal parts inside of Solid Edge, specifically ones that you've brought in from another CAD tool, you know that we have tools that will allow us to take geometry that's coming from another CAD system and transform it to Solid Edge sheet metal. And what that'll do is that'll actually create specific sheet metal features like tabs and flanges versus just generic part copy data. So when you bring geometry in like this, you may want to go through just at the start and see if you can transform it to sheet metal right out of the gate. So if I go to my tools menu, there's an option up here called thin part to synchronous sheet metal. And again, if you haven't adopted synchronous technology, this tool is also available in the ordered environment. So we're doing it here in synchronous just because I'm going to show you some other tools that are available. But let's right out of the gate try to convert this to synchronous sheet metal. We'll click that face. And you'll see that I'm getting a warning message. For example, the part contains cylinders that aren't or that are non-concentric. And so, typically when I see this message, the go-to is to look at those bend radii, to look at where those cylinders might be, to see if they are concentric and are being recognized as an actual bend. Um, I also look at sometimes at different corner conditions. So as an example, I may want to go through and just see under the inspect menu, I'm going to go here to inquire element and select this edge here. And you'll see that when I select that edge, it tells me that this is a B-spline curve. I would expect that to actually be a cylinder. Same thing here, if I pick the inside edge, it tells me that that is a B-spline curve. And typically with sheet metal, we want those to be actual radii, so cylinders that are concentric. And so what we can do too, and this is just a good habit to get into anytime you bring in data from an outside CAD system, is to do what we call an optimize. When you see this little I symbol next to the part copy, it's telling you that the quality of the body may be improved if you use this optimize command. Again, under the inspect tab is the optimize. And again, as the pop-up shows, is what this tool does is it increases the quality of the part. So if it does find B-spline geometry like what we just saw, it'll convert those B-spline um, areas to analytic geometry. So instead of it being a B-spline curve, it'll create it and make it a cylinder, which is analytic. When it's analytic geometry, it's a little bit easier to edit. So let's go ahead and use the optimize tool. And again, it highlights the body for us automatically. I'm going to right click. You can also hit finish up here and it'll go through and tell you what it was able to do. And again, just for purposes of time, we're not going to go through the details, but just to show you here what it did is if I go back to that edge or the inspect to see what that element actually is. And if I hover over that edge, now it's telling me that that's a circular arc. And same thing here, if I check the inside as well, that's also now a circular arc. And so that should have fixed now the conditions that the error message originally gave us. It should be able to unfold those when we go to our flat pattern or if we need to convert those to solid edge sheet metal features. Let's go ahead and try it again just to see what it's going to do. So again, we'll go back to that same option here. And again, it's still giving us that same error message, and not quite sure what that is. Maybe there's some other areas of the body that maybe we're having some issues with. And for example, maybe we're having some issues up here where the hem resides. And just by looking at this, I can tell that this does not look quite right. We've got kind of some merged faces here, which we may need to make some modifications to. There may be some other areas of the geometry where maybe the bends are occurring aren't quite in the right location. For example, on this end of the part, it looks like this bend is sticking out a little bit. Maybe it's not quite in the right location. So I'm just going to go through some simple tips and tricks that will allow you to do what we call some creative modeling. And what I'm going to do in this example is I'm going to actually create an actual sheet metal hem here within Solid Edge. So I'm going to actually get rid of the hem or the original hem that came in from the start. So to get rid of this, I'm just going to select that bottom face. And again, if I have my design intent turned on, I'm working in synchronous technology. Notice that as I adjust this hem, notice it's changing the hem on the other side as well. It's finding the coplanar condition. It's finding the bottom face on the other hem. I'm just going to simply pull that all the way up here and then click and just get rid of that geometry. Same thing, I want to go ahead and get rid of these two radiuses here on the top. I'm just going to get rid of those and have those be just standard flanges with no conditions there on the top. And we'll go ahead and put those in here in just a minute. The other thing that I'm noticing too is it looks like we have some merged faces. There should probably be a gap in here where the side face of this flange comes up. This doesn't look quite right. Let's see if the same conditions on the other side. On the other side, it looks a little bit better. So how can we do some creative modeling to get that same condition here as we see over here? And so what I'm going to do is come over here to the Project to Sketch tool, and I'm going to select this front face. And what I'm going to do is I'm just going to select the edges on this back flange here. And then notice how it copies that edge up here to the front. And then I'm going to grab this thickness edge here so that it creates this region up here on this front face. And then what I can do is just select that front region and then just use synchronous technology to get rid of that geometry so that now we have matching conditions on both sides. The other thing too that I may want to make a quick modification to is, again, let's move this the face of this flange and the face of this bend here. Let's move it to where it's supposed to go. Notice as I pull on it, again, our design intent is finding the coplanar face on the front. I don't want it to do that. So again, with just a keyboard shortcut, I'm going to hit the U key on the keyboard. That's just a shortcut to turn off the design intent, and I can move that flange all by itself to the proper location. So we'll go ahead and move it there. Let's look on the other side. We'll do that same thing. Move that to the right location. And then now that we've got those corner conditions set, let's go ahead and try that transform to sheet metal tool now. And again, if I go to that option and select the face, you'll see now that it converts those two tabs and flanges. And then just to round out this particular model, let's go ahead and insert back in, this time with a specific sheet metal feature here in Solid Edge. I'm just going to grab the edge there, and we'll do the same thing on this side, and we'll input that hem in as a solid edge hem. Gives us some more flexibility to make changes to that feature if we need to do some things later on. Again, I think the original part also might have had a break corner there. So obviously you can do that on all the corners. But so now we have specific sheet metal features, tabs, flanges, hems that we can go through and make a lot of modifications to if we needed to. So those are some little tips and tricks if you are getting issues with converting a model that you bring in from an outside source. Pay attention, use the optimize tool, and go through and look at those corner conditions, do some creative modeling if you have to, and then do the convert or the transform from there and make this a solid edge specific sheet metal part. All right, let's transition over to another example. I have this file open already. This is just an assembly of a sheet metal weldment. And I'm going to take a look at this part here on the back side. And this is going to be similar in terms of geometry of the one that we just looked at. It's going to be a little bit different. I'm going to show you some other tools to fix conditions where you can't get your imported sheet metal file to transform or have it create a flat pattern. So again, starting off the same way we did on the first part, let's start off by utilizing the optimize command and try to simplify some of the geometry. And then let's go ahead and see if it'll even transform for us right out of the gate. So we'll do transform to synchronous sheet metal, click on it. And again, you may have seen, again, the error message. This one's a little bit different than the first example. This one's not talking about the bin radii, but it's talking about different sheet metal faces. This one's not as easy to see, I guess, looking at it, from afar, but again, I typically will go to the corner conditions and see what's going on there. And if you look a little bit closely at these corners, these radii where these bends are coming together, they look a little odd. So what I'm going to do is go through, and I'm actually going to take this part to a condition where it's almost like a box with sharp edges. And I'm just not even going to mess around right now with the bin radii or these corner conditions. What I'm going to do is simplify this part even further and let Solid Edge do the work for me by automatically inserting in the bin radii for me, as well as having the corner conditions that I'm looking for. So the first thing I want to do is I'm going to get rid of the bin radii, and I'm going to utilize this tool here called Selection Manager. And as I select one of the radii, you're going to get this box that pops up. I want to find all the radii of equal radius. So it's finding all the outside radii for me. And then same thing, I'm going to select one of the inside radii. And again, say equal radius, and it finds all the internal as well. I'm going to delete all of those out of the model. And then I'm going to do the same thing. I'm just going to Windows select around all four corners and get rid of this geometry as well. Again, just a simple delete of the keyboard. And you'll see that, again, around all four corners, we should have just almost a box with sharp edges. And so there's a couple of different methods that we can use to transform this now to sheet metal. One of those is utilizing a tool where you actually rip the corners first. The other one is another tool where you can do what we call part to sheet metal, and that will allow you, really, if you just modeled a cube, you could essentially take that cube and have it take elements of that cube and have it create tabs and flanges automatically. So I'll show you both methods. Again, whether you're working in synchronous or ordered, this first example, it works in both areas. The first thing I want to do first, though, is you'll notice that I'm working in a part environment. This isn't even in the sheet metal environment. So you may need to go up to your tools menu first and click on this switch to option, and switch to will kick you over into the sheet metal environment. And so under the corner options, you'll see this option here called Rip Corner. And so Rip Corner, as I go around and select, notice that it automatically selects both the interior and the exterior edges when I go around to that corner. And then when I hit the green check mark and hit preview, notice how it puts relief into all four corners. And then by doing that, now gives me the ability, if I go to my tools menu, you'll see thin part to sheet metal. And then when I click on that face, you'll notice what it does is it automatically inputs or puts in all the bin radii for me. And you can go through based on your material table, you can go through and change that bin radius if you need to. So if you click under the material table, you can go to the gauge properties and you can specify what your bend radius actually is. So in this case, I've got 0.038. Let's just change it to the same value as the material thickness and then apply that. But again, you can go through and modify that and utilize that rip corner command to go ahead and add the proper relief. And then again, that should allow you at this point to go to your flatten and get the appropriate flat pattern. Okay. All right, I've gone ahead and brought the model back to its original state before we did the rip corner and the transform. I want to show you another alternative that you have if you are working with models of this nature where your corners are sharp like this. This one's located in the ordered environment. So if I right click and transition to that, and then again, if you go to your tools menu, you're going to see this option here called part to sheet metal. And if you look at the little glyph that pops up showing what this option actually is, what this will do is it'll take apart and again automatically put in bend radii and your corner conditions automatically utilizing this tool. So this is an option you can work with as well. So if I select on that, again, it's going to give you options. Do you want to utilize the bend radius that's located in your material table, the default value? Let's just do the same thing we did before. Let's go take that to 0.16. And then there are other options here, if you want to put in corner conditions and all the other different sheet metal features. But for now, let's just change the bend radius to what it is here. We'll click OK. And if you watch closely here, all I have to do is select the edge of the part. And notice what it's doing. It's trying to put a tab and then the edge that I selected a bend there. The other thing that you got to be aware of, and again, let's change the material thickness here to 0.16, is which side of that edge are we putting the material. So notice if you look closely, it gives us in a kind of a ghosted image the original part and then where our part is going to be if we select this side. And so what I want to do is I actually want to push this arrow and point it up so that it puts the material in the opposite location so that it matches with the original. Notice too that it goes and recreates, the tabs and the holes automatically. And all I have to do is go around to each of the edges, select each of the bottom corners, and then when I'm done, just right click. And notice what it did for me is it converted that box to sheet metal and it input in all my bend radiuses, corner conditions, and again, you have input for which side the material thickness is going to go on. But again, this is another way to do the same thing utilizing part to sheet metal. And then again, just to prove this out, if I go to Tools, Flatten, and select the options there, I get the appropriate flat pattern. So, I wanted to show you, different alternatives from creative modeling, making some minor adjustments maybe with corner conditions, maybe have to delete certain features within your sheet metal part, but there are, again, a number of ways to generate and convert imported data to appropriate sheet metal. Again, this last option we talked about, the part to sheet metal, you may start a design modeling in typical part modeling mode and then determine after the fact, this should actually be made out of sheet metal. So it doesn't have to be imported geometry necessarily. Works very well on imported geometry. But again, your native solid edge part models that maybe you started off in one direction and decide later on, hey, this should be sheet metal. This part to sheet metal option we just showed is another alternative to that. All right, we're going to come back out to the top level assembly of our sheet metal weldment, and now we're going to look at this component here. So let's open that. And again, if you look closely at this particular part, this looks like a relatively simple sheet metal part that should be easily transferable to solid edge sheet metal features. But let's start off with what we did with the other two examples. Let's just start by optimizing the model. We'll do that just as the start, and then let's try to go through and do a transform to sheet metal just to see what it does. And in this example, we're getting another error message. This one's telling us we have multiple material thicknesses. So if we look closely at this particular part, and you don't see anything really in the corners. We've got sharp corners here, but let's go to where the radius is. And if we look closely at where the radius is, it looks like this hole or this cutout is either partially consumed within that bend. It actually looks like it may even extend beyond that. Let's change um, our display a little bit so we see this a little bit more clearly. And maybe in this area is where we're having some issues with it not being able to transform. So again, I want to show how we can utilize some of our surfacing tools to recreate this sheet metal part a little bit more quickly. And so what I'm going to do is I'm going to come over to our surfacing toolbar. And what I'm going to do is just copy one of the material thickness sides of the faces. I'm going to go to the interior. I'm just going to copy those two faces. And then if I turn off the design body, you'll notice I have design body, which was the original design body. And then down here is surface body, which is what the surfaces that I just copied. I'm actually going to go through and delete the design body so that I'm just left with the surface bodies that I've copied. And so I got a little bit of work to do here. The first thing is I need to add in a blend between those two faces. I'm going to do that with our standard round command. If I go to our blend feature, you'll notice there's an option here called surface blend. And I'm going to select those two faces. And we have a 3/8 radius there. And then which direction do we want the blend to occur? And again, as I select down, you'll see it puts that blend back in. And then you'll also notice too that I have some gaps here. What I'm going to do is I'm going to fill in those gaps and I'm going to recreate the cutout from the part in the assembly later. And so if I go back to surfacing, what I want to do is just fill in these gaps. So we have a tool here called bounded surface. And we're going to just fill these gaps in utilizing bounded surface. And we'll do that here on both ends. We'll select all those little gaps. And what I want to do next is I just want to stitch all those together. Again, in the surfacing toolbar, we're going to go to Stitched. I'm just going to window select around all of those. And so now those form one stitched surface. And then I can utilize some tools. Again, this is just standard part modeling. I'm going to utilize the thicken command and just thicken this and create now a solid body out of that. And so what I should be able to do now is utilize that same tool called transition or transform to synchronous sheet metal. And now you can see it generates a tab and a flange. And so you might be thinking, okay, that's great. But what about those cutouts that went through the bend radius earlier? And so what I'll do is I'll save this, and then we'll come back out to the assembly file. And so as I go back to the assembly, you see that my part is there, but my cutouts aren't. And so what I'm going to do is I'm going to utilize a tool we looked at before. So actually, let's, instead of coming all the way back out to the assembly, let's go edit into my part again, and we'll go through. Actually, let me go ahead and close that first, and then we can edit into the part. And let's keep the rest of the assembly displayed. What I can do is come here to that same project sketch tool, and we're going to select that interior face, and I'm just going to select the part in which those cutouts are going to be relative to. I'm going to select the geometry. It just locates where that cutout's going to be. And then I'm going to turn off the background parts because now we have the region that we need. And again, you'll see how that cutout profile is transitioning through that bend. This is a nice little feature that Solid Edge has, is when I select that region, and I'm just going to window select both of those. As soon as I go through and try to cut this material, you'll notice there's an option here in our cut. It's called wrapped cut. And what it'll do, if I turn that option on, is as I drag through the part, it's very hard to see here because that bend is so shallow, but it'll actually flatten the part out, make the cut, and then fold it back. so that we get what we're looking for. And so I'm going to do the same thing on the other side. Excuse me. Let's go ahead and just window select that geometry. I'm going to turn on this option called wrapped cut, blast that through the part, and then notice it unfolds it, cuts it, and then bends it back. And so if we turn on the background components again, you'll see that my cutout is located exactly where it needs to be. So hopefully these sheet metal tips you found useful for different ways to be creative in your modeling, and just some different tips and tricks on how you can take both native as well as imported parts when you're working with sheet metal and make those available to create flat patterns for manufacturing.